In this video, we're going to derive the sum and difference formulas for tangent. I'll be perfectly honest, I've forgotten what they are. I taught trig last semester. I had them accidentally memorized the week or weeks that we were using them, and I have since forgotten them. Okay, so I don't remember what they are right now, but I know how to get them. Okay, and that's what I want you to have. I'm fine if you memorize, on purpose or accidentally, the sum and difference formulas for tangent. But I will hold you responsible for being able to derive them, which is what we're about to do. Okay. So if I want to find tangent of u plus v, okay, I'm going to just use my quotient identity. I know that that is sine of u plus v over cosine of u plus v. Doesn't matter what the argument is, tangent of something is sine of something over cosine of something. And that something is what we call the argument. That's the input to our trig function. So now I can use my sum formulas for sine and for cosine. Okay. So the sum formula for sine, sines are the social ones, so that's sine u cosine v plus cosine u sine v. Cosines, those are the antisocial ones, so that's cosine u cosine v minus sine u sine v. Now, that is a formula for the sum formula for tangent. That's not the version you're going to see in the textbook, and that's not the version I would want you to derive, although this is how you get there. This is the first step. If I wanted you to derive it, I would say, give me the sum formula for tangent and express it in terms of tangent of u and v. So right now, I don't have any tangents in this formula. I've got sines and cosines. So there's a trick for switching to this version of the formula to an equivalent version that uses tangents instead. That trick is to multiply by a fancy form of 1 in the form of something over itself. And I have to think, well, what do I want? If I want to get to tangents, I want to have cosines in the denominator. So what I'm going to do is I'm going to create a complex fraction. I'm going to multiply by 1 in the form of the reciprocal of both cosines, cosine u times cosine v, over itself. Okay. So what that's going to do is this is going to turn this into a massive complex fraction. I'm going to distribute this cosine u cosine v in the denominator to each term on top and to each term on bottom. So on top, my first term was sine u cosine v, and I'm going to divide that by cosine u cosine v. Plus, the second term was cosine u sine v, and I'm going to divide that by cosine u cosine v. Okay, and then on bottom, we've got cosine u cosine v, and I'm dividing that by cosine u cosine v minus sine u sine v divided by cosine u cosine v. Okay, so this looks like an atrocious mess, but it actually simplifies quite nicely. Notice here in this first term on top, the cosine v's will cancel. I'm left with sine u over cosine u. That's tangent of u. Here, the cosines of u will cancel. I'm left with sine v over cosine v. That's tangent of v. So the top just becomes the sum of the two tangents. On bottom, everything cancels here, leaving me with a 1. And then I'm subtracting this. But notice, I could view that. I could sort of pair up the trig functions that have an argument of u and the two that have an argument of v. I've got sine u over cosine u, that's tangent of u. Sine v over cosine v, that's tangent of v. So it's 1 minus the product, tan u times tan v. So that is the version of the sum formula for tangent that you're going to see in the textbook, and that's what I would want you to derive. I would just specify, derive the sum formula for tangent using the sum formulas for sine and cosine. Express your answer in terms of tangents. Okay. So that's sort of the important trick to remember, that if you want to switch from sines and cosines to tangents, you need to have those cosines in the denominator. kind of cool. Now, I could do something similar with the difference formula. I'm going to actually just write out the result because the work would be so similar. So that's the sum formula. If I'm looking at tangent of u minus v, of course that is just sine of u minus v over cosine of u minus v. But we just saw that the difference formulas for sine and cosine involve the same terms but the opposite sign. So that's going to translate into this involving the same terms but the opposite signs. So we will have on top tangent of u minus tangent of v, and on bottom 1 plus tangent of u times tangent of v. Okay. All right, excellent. So we've now got all of those formulas, and in the next video we're going to start actually using them to evaluate some trig functions.